Hello, my name is Igor Uspenskiy. I am senior engineer for PostgreSQL in Rambler company. Rambler Co is about a lot of publications, services and projects. These projects grow and new ones appear, and that's why we need a reliable, fault-tolerant, scalable and reliable system. The load on PostgreSQL are various. This load includes applications, monitoring and robots, and the mode of interacting with the operating team is a separate aspect of our work. In the past, for every cluster, we provided their own servers and diversified operational system of PostgreSQL versions and so on. What tasks did we have and why did we decide to do it? This should be about speeding up of database service provision. So after a database is created, just several minutes pass before the database is created. Optimization of resources. We can combine several clusters on one server. Unification of configurations. Quick entry into operation and so on, and the number of servers and resources used by this project. PostgreSQL, based on SaaS model, is composed of the following elements: 3 data centers, dynamic routing of BGP with a single entry point, that is one IP address, etcd cluster front-end layer, nodes of databases with PostgreSQL continuous backup, and QoS Centra 7 operational system. Monitoring and alerting of parameters. That's about 100 machines and 300 databases. Every loop has a logical division and a separate installation. Synchronization of cluster between contours is also possible. We have 4 loops. Production loop. The access to it is limited. It can be provided for production infrastructure only. Infrastructure loop. It is referred to infrastructure components and the access is restricted as well. Also, we have a special loop for load testing, new functionality and backup check. Let's look at the scheme of the main loop and logical loops of related systems. There are 3 data centers. Single point. I'm describing the scheme from its upper part. Announcement of front-end servers that receive connection in the entry point is conducted through a rejector, and it does not depend on the network infrastructure of PostgreSQL as a service, so we can use it in a public cloud, for example. Front-end layer. In every data center, SpeechBounce, AgProx and Condit. Database nodes managed by Patronic have REST API through which we can learn the rule of PostgreSQL, whether it's master or standby. For one node, we can have several PostgreSQL instances with similar or different major versions. Coordination and consistency. are provided by a distributed coordination system that is addressed by Petroleum. Thanks to 3 data centers, we have a quorum, and we can lose one data center, and etcd nodes loses quorum. PostgreSQL master is switched on, and the left, the remaining data centers start voting. Also, we have backup layer. We use PG instrument here. Let's look at front-end scheme. Incoming connection is processed by netfilter that randomly divides connection for 4 working processes, so we have a vertical scaling. But here we have an additional element, and if necessary we can exclude front end from the balancing, so the announcement is removed here. Here is the wait logs. Distribution of connection on PG bouncer. Every database has 2 entries. PG bouncer, depending on the name of the database, master or slaves, takes a decision. Here in these 2 lines you can see database master and database slave. Every level is related to its own port. P-tables rule. Random module distributes connection to PG bouncer ports. 3 instances and unified configuration of database. HA proxy instance per cluster. HA proxy is launched as D-service system. Line XX start. You can take a look on it. Here we can see 2 backends. One of them is master backend, the other one is replica. The master is on the left, replica is on the right. For each proxy to understand the role, it has to check the HTTP status. You can check it in option HTTP checks replica master. It checks status 200 and goes to port 8008. So in backend, master is only one, and all the rest are not masters. And on the right you can see backend replica, only one down master because it is not replica, and all others are up. Here you can see a scheme of database node. We can have one or several clusters here. You can see Petroleum that manages PostgreSQL. It launches, stops, promotes and demotes. Transfers to data reading mode. Petroleum is launched as a systemd service. It provides a lot of opportunities, including the opportunity to execute your own method of replica creation. You can see the extracts from configuration on the right. Create replica method. At first, we have backup. After that, it is described through basebackup command, and depending on the result, Petroleum makes the choice. The priority is the first one, and if it was successful, we can launch it. Creating replica is always a load on a cluster on the permanent storage, and the response time can be too long. Quite often, we have to create a replica without a load on a cluster. For example, if the load on nodes has increased. Let's take a look at the logic. In order to guarantee the presence of wall segments that master can reuse while we are creating a replica, we launch wall on replication protocol, making sure that we have relevant seed. We get information from PG control checkpoint. We can select view from it using command select from. We restore backup, and if the necessary wall segment is in archive, we launch PostgreSQL with recovery target seed. And just in case, we need to remember to switch off mode archive. If PostgreSQL when restoring the archive, will not find recovery target, it becomes a master, and we have one configuration, so it will start archiving its wall, and unnecessary wall segments will be created that will spoil backup, because these will be wall segments from another master. Just in case we are to determine the number of port where client connections will not come, we wait till the recovery process from archive finishes, check that PostgreSQL is in pause mode, and if alert target is not found, the replica that is being recovered becomes a master. That's why we have to make sure that this is a pause mode. We can choose this state in shutdown mode, but we cannot guarantee that shutdown resulted from recovery from an archive. After that, we stop PostgreSQL, and when Petroni starts operating, the cluster is launched, PostgreSQL replica is launched, and the work continues. For the purposes of development and testing, a cluster can be transferred, or separate databases between the loops can be transferred. Let's imagine a typical task when a developer needs a database for their daily activities, for the purposes of testing, for example. And if we restore a database logically using PGStore, if this database is big, this will be a problem. And when restoring logical backup, this will be a different database, not the database that we use when working in production. So we get only the logic. We lose bloat, we lose bags and indices, and it is important, for example, for pre-production testing. And there is another problem. Even big databases, when transferred through basebackup, so we created basebackup, then rolled it out, into a cluster, but you will not place a database in each cluster in production. In your cluster you have, for example, 40 databases. They are different in terms of size, and you need to restore one or two databases, big ones or small ones. In that case, you have a problem of excessive resource consumption if you use basebackup, because you will have to recover the whole cluster. That's why in case of big volumes, only the delta of changed files should be copied. Also, there is a problem of data impersonalization when they are transferred from production. Configuration management. System configuration is conducted through a sort stack. Everything is automated. Different settings up to the generation of monitoring targets. So having a lot of clusters, a lot of databases. Assembling a relevant configuration is quite complicated if we do it manually. We use Prometheus, it has labeling, and using the late we determine what target is related to what project, to what cluster, and to what environment. That's why heterogeneity and MVCC remained in the past. Here you can see Patroni prod on the left. After that you can see cluster mark and the name prod01. This is the cluster composition. Here we have 3 nodes. Each node may have its own port. It is regarded in the whole system. On the right you can see Patroni dev. This is a dev loop, and here you can see an example of recovering one database from the whole cluster. So we recover it from prod loop, take prod01 cluster and recover only one database. And we have database pre-prod cluster. So we can use real data that were not changed and also I wanted to mention something about database. The database should be recovered with regard to data ID. So we receive data ID in advance, memorize it, conduct a base backup. After that, we collect metadata for all the files in the cluster. And when recovering one database, we exclude all databases apart from this data ID. Horizontal scaling and cluster transition includes the following stages. We launch instance on nodes, so Patroni launches PostgreSQL. We do it using automation. If necessary, Patroni has a lot of opportunities, including callbacks, and we can launch any shells, any programs. Conf.D configures HTA proxy. It is based on contents and in etcd that provides for the integrity of configuration. It can get information for the new replica and record HE proxy in configuration. And transition happens in a similar way. At first we conduct scaling, and after that we switch master. An important point when creating service on the basis of SaaS model is monitoring. So it should be sufficient for independent understanding of production, so that the owner of the service could independently analyze the historic period or the current state without the support of engineers. All products have a unified group of dashboards. They are divided into 3 groups depending on the degree of detailization, starting from the traffic lights. So this is the status that shows a snapshot at a specific point of time. At this time, this status panel is constantly improved. Starting from the traffic lights and finishing with the monitoring of SQL queries with PG status statements. So we have historical metrics from PG status statements and about 60 charts. For example, we can check average time of query historically. So at what point, what query was made and the way it behaved. You know that in PG statements there are a lot of fields, so it's only one example. We can also check what query and when was read. And there is a view through the interface. PG status statements. It has a convenient aggregation. Here we can see the amount of time that was necessary for this query. Average time of execution multiplied by the number of executions, so we can understand how much time this query worked. For example, query 1, does it bring us that much money for us to spend 2,000 minutes for it, for example? Or we can conduct explain, analyze and visualize the query the way that the scheduler represents it. Let's summarize. Does PostgreSQL and the infrastructure suit the burden of service on the basis of SaaS model? Yes, it does. What did we manage to achieve? Single point, single entry point for everything. Division and easy maintenance. Status monitoring with notification. The scheme of cooperation with the team of development. The system is fault-tolerant, scalable, and it has continuous backup. What do we want to achieve? We want the sun to shine always. Automation of processes, provision of resources, automated search for bottlenecks in the databases with recommendations on their elimination. And, of course, there is no limit for improvement. We can rewrite as Z configuration. In that case, it will will be easier for us to work with backups. And speaking about this project in Rambler, provision of service on the basis of SaaS model appeared a year ago, so the best is yet to come. Thank you. Do you have any questions? Hello, my name is Evgeny. Do you provide any trainings, for example, to emulate the switch of a data set? Yes, and besides, we also conduct practical trainings. Do you cut power? Well, we do not consider hardware problems. I mean not, because it happens every week. Some memory problems, for example, in that case, the process is crashed. And we also want our equipment not to have servers of one project, one cluster, and so on. And also network segment failed due to problems with the network equipment. Due to clusterization at their level. And one switch fails, the other one takes its role. That's where traffic changes. And it's quite a burden for our network. Disconnection can occur. That's why failover happens. And we have almost lost data center due to isolation of etcd of one node. Roughly speaking, we were lucky. If one node of etcd fails, it's okay, because we have a quorum. Two of them will work and Petronia will switch to other nodes. But Petronia was not switched, and we had to do it manually. So the majority of problems have already been experienced by us. Thank you. Thank you for your presentation. It was very interesting. I would like to specify. Do you place different clients in different databases in one instance, or do you create separate ones for every client? I did not understand it from your presentation. Well, first of all, we forecast the project's activity, its profile, and interaction with the database. After that, we analyze the profile of current load for one cluster, and we decide whether we can place this database there. Or, if the project is big, we divide it into a separate cluster. Also, it can be convenient if a database of one project, if there are several of them, in order to divide them logically. For example, we have a cluster with 40 databases. And if something is wrong with one database, we will have to conduct manipulations with the whole cluster, so we will influence other databases as well. That's why we should better logically divide them into another cluster. We create new databases for one project in one cluster, and we use only this cluster, and we do not touch the databases of other projects. So we analyze the load, we select it on the basis of the profile, and we logically divide it. Okay, so on the whole, you have a communal base, but still you decide where to place them better. But how do you control the isolation of resources between these databases? So there may be a situation when one project has a database, and for the other databases apart from them, some backends failed, and the database occupies the whole drive, so all 40 bases suffer. What can you do in that case? Unfortunately, there are no inbuilt means of PostgreSQL, but I know that the work is underway that it's necessary to provide the division for load measurement. But as I told you, we try to forecast everything, even if it fails. Well, there are some public projects with heavy load. We place them into a separate cluster. If it is one cluster, it is transferred to hot swap servers and stays there until this problem is solved. If this is a failed database in a cluster where there are a lot of other databases, then well, unfortunately, we will have to do it manually. We can take it manually into another cluster, create a replica that will become a master for this database, transfer traffic to it, or we can expand the cluster and transfer master to SSD, for example. It should cope with it and solve this problem. Thank you. So, you have not tried various C groups and other things for specific bases. Within one instance, C group will not help. But anyway, if we restrict clusters on one server by C group, well, we want to implement that. Thank you. Do you have other questions? Thank you for your presentation. You used only the means present in Petroni, or do you write your own solutions? You mean solutions for fault tolerance? Well, as I know, Petroni writes on the basis of CD. And what about... I'm sorry, I haven't heard you. So, do you write something yourself? No, we do not do it. So you use etcd in V2 version, L3 version, with authorization without it? No, I'm kidding. Have you experienced any problems when configuring? So the number of keys that you tried to take is constant? You mean within one etcd cluster dividing keys? No, we have a prefix and we want to export specific number of keys. So we take everything that we have, and from V3, well, that's a problem. Code D cannot take everything that is present there. So if you want flexibility, you have to do something about it. It's an interesting question. Thank you. It's a very tricky thing. I tried to connect etcd and we didn't manage to do it because when the number of bases is variable, I cannot see them. We'll check it. Thank you. Thank you for your presentation. My name is Vladimir. The question is as follows. Regarding communal bases, what about the rights of different users? For example, that they should not see the list of other users' databases. And is it difficult? No, we do not use it. If necessary, we can conduct research. But a list of bases, maybe some public things can be available. So you have internal users of the service. Yes, normally these are internal users. It's not for external SaaS, it's for us. So we are SaaS groups that provide infrastructure for our services. Thank you. Do you have other questions? I just remember that authorization with certificate is available with special certificates. So you either do not have certificates or do not have authorization. Thank you. On production loop, we have V2, and for the rest, we introduce this thing. Well, we have time left, so you can ask your questions. Well, if you have no questions, that's it. Thank you, Igor, for your interesting presentation. Oh, we have the last question.
So, my question is, I'd like to ask if this is the way to fail back. So normally you have a replica, you promote it, and after you promote it, you have to PG rewind all the other slaves. Is this correct so far?
You mean replicas is well?
I'm only talking about the simplest failover.
Not understanding. Sorry.
Okay, I will ask afterwards.
Okay.
Yeah.
We have one more question. Have you tried to do switch over? Yes, a lot of times. And what can you do with bouncer so that it would remember about the previous master? In the upper part, you can see database broadmaster. The lowest line on the slide shows 5100 port. That is database broadmaster goes to 5100 port. And front-end master addresses 5100. That's why we have default backend, and only one master is available from it. Is it Postgres or Bouncer? 5432 is PostgreSQL. We have no Bouncer. Bouncer is here. 6000 port. 6000 pre-routed NAT goes to jump Bouncer, and after that we have Depon 6000, and it distributes connection. Thank you. Pictures are easier for understanding compared to letters. That's true. If you do not have any other questions, let's thank our speaker. Thank you for your attention. Thank you, Igor.